Today we are going to discuss ray optics lens immersed in a liquid topic. It is going to be a generally important topic in case of NEET and JEE mains exams. Okay, so let us see that ray optics topic. In that, lens immersed in a liquid. Okay, so before going to see this topic, I would like to recall the formula, that is lens maker's formula, which I write here. The lens maker's formula 1 by f is equals to, it is mu for glass divided by mu for medium minus 1 into 1 by r1 minus 1 by r2. So what is this? Actually, this is called as lens maker's formula. Lens maker's formula. And here the terminology, if you try to understand, here mu g is a glass refractive index, generally it is 3 by 2, and mu m is a medium refractive index, okay, refractive index of medium. Most of the books, they will consider the lens maker's formula as mu g by mu m as mu only they will consider. I mean, this value they will take it as mu, but general formula of lens maker's formula is this one. Okay, so we are going to see this. In this case, when a lens is in air, say it is convex lens, okay, convergent lens. So in air it is, so focal length in air, you can say 1 by fa equals to mu g by 1 minus 1 into 1 by r1 minus 1 by r2. Okay, but the same lens is immersed in a liquid. Okay, so same lens is immersed in a liquid, so the focal length in the liquid, let it be fl. Now in this case, both side of the lens, it is going to be liquid. Okay, so this is mu g. Now the same formula, this formula for this case is going to be 1 by fl equals to mu for glass minus mu for liquid minus 1 into 1 by r1 minus 1 by r2. Okay, so we are going to take the ratio of these two equations. If you take the ratio of these two, you will get fl by fa, that is focal length in liquid divided by focal length in air, and it will be equals to, it is mu g minus 1 divided by mu g by mu l minus 1. This is the formula finally you will get, and from here you can rewrite the focal length in liquid equals to this quantity mu g minus 1 divided by mu g by mu l minus 1 whole multiplied with focal length in air. Okay, so this one is a final formula that we can have, and problems will be asked based on this. Okay, so how the focal length will be changed, like nature of lens also will be changed depending on the value of liquid's refractive index. Okay, that I will be explaining after taking this. Okay, so let me write the formula what I derived here. So the focal length in liquid equals to mu for glass minus 1 divided by mu for glass by mu for liquid minus 1 whole multiplied with focal length in air. Okay, so this one here we have some number of cases, like 3 possibilities we can have. Okay, this you can remember as a shortcut. Okay, so case 1, suppose the liquid's refractive index is less than the glass refractive index. Okay, so if liquid's refractive index is less than the glass refractive index, this is mu g by mu l will be greater than 1. So mu g by mu l minus 1 will be positive. Okay, so we can say this total ratio will be positive, and we can say that focal length in liquid is going to be some positive constant into focal length in air. So this positive indicates the nature of lens is not changing in the liquid. I mean, if you are using the lens in air, it is convergent lens. Okay, if you are using in a liquid whose in a liquid whose refractive index is less than the glass refractive index, then it will behave as a convex lens only. Okay, it will not behave as a concave lens, because of the fact the refractive index of liquid is less than the glass. Okay, so we can say schematically, like in a liquid, if you consider the lens, it is actually convergent lens, so it will converge the light rays anyway. It will converge the light rays. Okay, so this is going to be focal length in liquid. So what will change? Only the focal length will change. Nature of the liquid will not change in case of first one. That is when liquid's refractive index is less than the glass refractive index. Okay. So second case, if liquid and glass has same refractive index. So in this case, what happens to the denominator? This one, it will become 1. Okay, that is what mu g by mu l will be 1. So 1 minus 1 will become 0. Something by 0 is going to be infinite. So we can say focal length in the lens becomes infinite. So for which object or for which instrument the focal length will be infinity? For a glass plate, it will become infinity. That means the lens, it will behave as a transparent glass plate. That means the lens will disappear. Okay. Disappear. It will be existing physically there, but you can't see that because there is no refraction. There is no reflection. It will be completely transmitting the light as shown. If this is the lens, then it will go this way. It will not converge or it will not diverge. Okay, this is a case situation actually. When the glass refractive index and liquid's refractive indexes are equal. Okay. So next possibility, if the lens refractive index is greater than the glass. If it is greater than glass, then what would happen to this ratio again? It will become, less than 1. So mu g by mu l will become less than 1, so that this subtraction will be negative, so that FL will be the focal length in liquid equals to some negative constant into focal length in air. Okay, so how much is constant? That depends on these values. Okay, but it is going to be negative. What is the meaning of this negative? I'll tell you here. The meaning of negative is, in air it is behaving as a convex lens. If you immerse in this liquid, then it is behave as a concave lens. Okay, so convex lens in air, it is behaving as a concave lens in this liquid, because of the fact the liquid's refractive index is greater than the glass refractive index. That means if I draw the diagram, it will be diverging the rays. Actually convex lens has to converge the light rays in air. Okay, but it is in a liquid which is having greater refractive index than the glass, so it will diverge the light rays like this. Okay, so it may be, this is the focal length.